Hello, and welcome to our brand new series on Azure Container Apps. My name is Ian, and in this video, we're going to be covering what are containers, how does Azure Container Apps fit into modern development, and why it matters to you for your projects. By the end of this video, you'll have a clear understanding and idea of what containers are, why they are so popular, and how Azure Container Apps, also known as ACA, can help you build scalable, modern applications. Let's start with the concept of containers. Think of them as lightweight, standalone packages that include your code, runtime, and system libraries. Everything you need to run in a nice little container. From the diagram I'm putting up on the screen, you can see that traditional VMs each run their own operating system, while containers share the host OS kernel. This makes containers lighter and faster to start compared to VMs. Now let's talk about a couple of reasons that containers have become so popular in modern software development. The first is that containers encapsulate code and dependencies. Containers bundle everything you need in an application. Libraries, runtime, system tools, everything in a single package. And this is important because you don't need to install every dependency on each server or environment. This leads to fewer versioning issues, smoother deployments, and far less "it works on my machine" syndrome. In addition, containers are lightweight and faster to start up than VMs. Containers share the host OS, so they don't need their own operating system. As a result, they launch in just seconds rather than minutes. This is critical for microservices or auto-scaling scenarios where you might rapidly spin up or shut down instances based on demand. And finally, it provides a consistent runtime environment across platforms. If it runs in a container locally, it'll run on the cloud, no matter the host OS or infrastructure. This consistency boosts developer productivity and reduces environment-specific bugs. Thanks to these benefits, portability, speed, and consistency, containers have become a popular integral part to modern DevOps and cloud-native approaches. Now let's move on specifically to Azure Container Apps, or ACA. This is a fully managed service from Microsoft Azure that makes it easy to run and scale your containerized applications without dealing with servers or Kubernetes clusters directly. As you can see, you can push your container image to a registry like Azure Container Registry or Docker Hub, and then Azure Container Apps deploys, routes, and scales it automatically. No manual provisioning of VMs or Kubernetes is needed. Let's break down specifically what ACA offers. It offers serverless containers in Azure with no manual infrastructure provisioning. You don't have to spin up virtual machines, set up networking, or install container orchestrators. ACA abstracts those details away so you can focus purely on your containerized app and its settings. In addition, no cluster management required. Azure handles Kubernetes behind the scenes. ACA is built on top of Kubernetes, but you don't have to be a Kubernetes expert. Azure manages the control plane and handles updates, security patches, and scaling mechanics. It allows you to just define your app's requirements, for instance, your CPU, memory, etc. And finally, you pay only for what you use. Scale to zero. It saves cost when your app is not in use. Azure can spin down your application completely. You won't be charged for compute when it's idle, which is huge for cost savings, especially for low traffic or event-driven scenarios. In short, ACA delivers a serverless container experience, freeing you from cluster management and letting you pay only when your containers are actively running. Now let's explore three main concepts that define ACA's functionality. The first is simplified deployment. You provide a container image, for instance from Docker Hub or Azure Container Registry, specify a few settings like environment variables, ports, or CPU memory, and ACA takes care of the deployment details. This lowers the barrier to entry, especially for teams that don't want to wrestle with Kubernetes configurations. In addition, there's auto-scaling, also known as KEDA, which leverages, KEDA stands for Kubernetes-based event-driven auto-scaling. It scales your containers up or down based on triggers like CPU usage, queue length, or even custom metrics. When your app experiences high traffic or large queue backlogs, ACA automatically adds more container instances. When traffic dies down, it scales back, ensuring you only pay for the capacity you actually need. And finally, containers are microservices and event-driven. If you're building a microservice architecture, each container can run its own app, update independently, and scale based on its specific need. This decoupled model is especially powerful for event-driven systems, where you might have asynchronous workloads, triggered by messages, events, or timers. Together, these concepts, simplified deployment, auto-scaling, and microservices event-driven support, mean you spend less time on infrastructure and more time on developing features. So when is the right time to use Azure Container Apps? Let's highlight some common scenarios. APIs and web services are a great example. If you have REST APIs or front-end web applications, ACA can automatically manage ingress, routing, and scaling. This is perfect for unpredictable traffic patterns, ensuring your service remains responsive under load, yet cost-effective during off-peak hours. In addition, ACA is a great tool for background jobs and workers. If you're processing messages from a queue or doing scheduled tasks, ACA can spin up containers when there's work to do and spin them down when idle. This is ideal for batch processing, data transformations, or any job that benefits from ephemeral scaling. And then finally is the microservices architecture. Like we touched on previously a little bit, a microservices approach typically involves multiple smaller, independent services. Each can be packaged as a container in ACA, allowing them to scale, update, and fail independently without bringing down the entire system. In each scenario, ACA's serverless nature and auto-scaling make it easy to adapt to changing demands. And that brings us to the content for this episode. So let's recap what we covered. We covered a lot of ground. We talked about containers, how they encapsulate code, dependencies, are lightweight and fast, and ensure consistent runtime consistent runtimes across different environments. We also then talked specifically about Azure Container Apps, a service that gives you serverless containers, no cluster management, and even pay-per-use pricing, even allowing scale to zero, offered on Microsoft Azure. We talked about the key features of Azure Container Apps, simplified deployment, auto-scaling, and support for microservices, event-driven workloads. And then finally, we ended with some use cases where ACA can be used, for instance, APIs, background jobs, and microservices architecture. If any of these points caught your attention, stick around for this series, where we'll dive deeper into the power of ACA. We'll also explore best practices, cost considerations, and operational ease. Thank you so much for joining us for this kickoff. If you found this video helpful, hit that like button, subscribe, drop your questions in the comments, and see you in the next video.